All right, so now we're going to put this new skill of isolating variables to use to solve a system of equations using a method called substitution. Okay, this might be a review for some of you because I think that you learned a little bit about this last year. So what we have here is a system of equations, and it looks a lot different than any system that we've seen before. Because normally it's y equals mx plus b, and you have two different equations like that. You set them equal to each other, so on and so forth. This is a little bit different. Okay, so we're going to follow some steps. Okay, this is still a system of equations, and I'm going to tell you now it's not really any harder to do. It's just you got to follow these steps. Make sure you're really clear and precise. The first thing that you need to do is get an equation, or isolate a variable in one of the equations. Okay, so we want to isolate a variable in just one of the equations. And you're going to have to pick which equation. Now, I have two equations, and it's very obvious to me that this equation is going to be easier to do that. So that would be the first equation. Why is that easier? Well, it's easier because it already has a y. It doesn't have a coefficient. Okay, and that means that it's going to just be less steps. You won't end up with decimals, that kind of thing. So that's going to be better. So what we're going to do is literally take this equation. Okay, I'm going to take this. I'm actually going to write it over here so that we can work with it a little bit. So we have 2x plus y equals 14. Okay, well, using the same method that we just learned, we're going to isolate this variable. So we're going to solve for y. Remember, that's what isolating a variable means. All I need to do is subtract 2x to both sides. I'm going to ask the question, are these like terms over here? Those cancel out, but over here, are they like terms? And you should have the answer, no, they are not. So therefore, it's just going to be y equals, pull down the y, 14 minus 2x. Okay, so first step done. Second step, you're going to plug the expression that you get into the other equation, and it has to be the other equation. Okay, so what does that mean? That sounds like fancy terms. Let's just be really clear about what I mean. We've now just rewritten this equation. Okay, so this equation and this equation are exactly the same. They're just rewritten. Well, y equals 14 minus 2x, and I have a y in this equation. So what I can literally do is take this expression that we got, okay? This expression, we're going to take this and plug it in for y, okay? And just like we do when we plug in anything, we're going to use parentheses around that, okay, when we plug it in. So let's see what that looks like. So we have 5x minus 2. Okay, then we're going to put the parentheses. So then we have parentheses 14 minus 2x equals negative 1. So all I did is took that and plugged it in to this y. So that's what we have now. Okay, now we're going to solve for x. Okay, so our third step is to solve for x. Okay, and it looks like a lot, but it's actually not once we start breaking this down. So first thing I notice is if I look at this side, we have x's everywhere. We have an x over here, and we have an x over here, and we have this parentheses. We need to simplify first. So you're going to take this and distribute. Okay, anytime you have a number before a parentheses, you need to distribute. Okay, so negative 2 times 14 gives me negative 28. Negative 2 times negative 2 is positive 4x. So negative 2 times negative 2x. Remember, that negative needs to be attached, okay? Whenever you have negative 2 here, you're multiplying the negative and the 2, okay? Negative 2. Okay, we'll pull down everything else. So we have negative 1. We still have our 5x over here. So we have 5x minus 28 plus 4x.